If you could count one star per second, it would take you over 300 trillion years.
When you get familiar with the constellations, you can tell time and you can tell the seasons by the stars.
Just a reminder to me of how awesome God is to have made all those. It's summed up in this little phrase, He made the stars also.
As an astronomer, I'm always amazed there are people out there who can look up at the night sky and not be blown away with what they see.
The proper response is worship.
When we look up into the night sky, we're in awe over the stars that stretch out above us. We're faced with how small we are in comparison to the greatness of the vast universe. And yet, the Genesis account of creation simply says He made the stars also. It makes us wonder why God made so many and how they fit into His creation.
Well, on the fourth day, when God makes the heavens, it says that He makes the stars for signs and seasons and days and years. With the stars, when you get familiar with the constellations, you can tell time and you can tell the seasons by the stars. But I think even more, all of Scripture says that the heavens show God's glory. So I think it just shows His infinite energy and His artistry that He just flung the stars across the sky. So I think that's the main reason, showing His infinite glory.
Revelation 4:11 says, "Thou art worthy, O Lord, to receive glory and honor and power, for Thou hast created all things, and for Thy pleasure they were created." So God created for His own pleasure. Maybe that explains why He created an incredible universe full of stars.
There are a number of things that are fascinating about stars. The scales involved are just outrageous. You can't even comprehend the distance to the nearest star, let alone the farthest one that we can observe. It's just beyond imagination.
We use big numbers in astronomy, by the way. We talk about millions and billions of light years as if we really know what those mean. And I don't think we do. I don't think I really do. I throw it around, but I can't comprehend it either.
I think we all, if we go out under a really dark sky at night and see the overwhelming number of stars and just the beauty of the heavens, I think we can all be overwhelmed with that. And of course, we're not unique in this. I mean, people from all of history have had this experience.
Stars are beautiful when you look at them in the telescope, especially when you see a cluster of stars, like a globular star cluster. I was looking at one a few nights ago. It was just stunning. You just have to praise God. And you know, the Bible says, when you look at all those stars, 100,000 in a globular cluster, the Bible says God calls them all by their names. God has a name for each one of those stars. So it says something about His majesty, about His power. It's just a reminder to me of how awesome God is to have made all those.
God calls them each by name and He counts them, which is impossible for humans to do. And I think the names He has are probably pretty good names too. Ours are things like GSC 1046 938 or something, which just rolls off the tongue, doesn't it?
It's estimated that there are over 100 billion stars in our galaxy alone. Some estimates put it up to 400 billion stars in our galaxy. And it's estimated that there are at least 100 billion galaxies in the universe. So assuming that ours is typical, you could multiply that out. There are a lot of stars in the universe. And that's just the universe that we can see at the moment. So who knows if there are even more than that.
All I can tell you is the number of stars that we have photographed and observed. 10 followed by 22 zeros. In words, about 10 billion trillion stars. But of course, that may just be the first drop in the bucket. Every year, new telescopes look further and see more and more stars. That's how many we know of, but surely there are more than that. It's a large number, 10 to the 22 power.
And again, God calls them all by their names. We don't even have that many words. Incredible. And I love the way the Bible describes the creation of all those hundreds of billions of stars and hundreds of billions of galaxies. It's summed up in this little phrase, He made the stars also. As if it was just so easy for God to make all those. And of course it was, because He's God.
When thinking about the number of stars God made, we're reminded about the account of Abraham. In Genesis 15:5, God is speaking to Abraham, and he took him outside and said, "Now look toward the heavens and count the stars if you're able to count them." And he said to him, "So shall your descendants be."
It's interesting, the Bible describes Abraham's descendants as being as the stars of heaven and as the sand which is upon the seashore, which it says, which cannot be numbered for multitude, indicating a humanly uncountable number. It's a metaphor.
Not that that means there's 10 to the 22 of them, it just means you can't count them, that it's a large number.
It's interesting, though, that the Bible has had a correct perspective on this when, in many times, in many cultures, what the Bible had said would have actually been laughed at because it went against the common knowledge of the day. And there's about 3,000 stars visible to the eye.
Well, you know, you can estimate how many grains of sand there are on all the seashores of the whole planet. Engineers are good at these kind of approximations. And if you do that by one technique, you end up with the very same number, 10 to the 22 power. After all, like in 1 cubic inch of sand, there may be 1,000,000 sand grains, and then you would have to extrapolate that, guessing how many beaches there are in the whole world.
Sir James Jeans from the earlier part of the 20th century actually estimated that the number of stars probably is equivalent to the number of grains of sand in all the world's beaches, which I think is interesting. I think he must have known about the promise from Genesis.
But it's interesting that they do come out to be in the same ballpark, the number of stars or the number of sand grains.
The prophet Jeremiah wrote that the host of heaven cannot be numbered, nor the sand of the sea measured. Now, at the time he wrote that, that would have been considered ridiculous, because all they knew of the stars was what they could see with their eyes. They didn't have telescopes. But yet, here we are, thousands of years later. Now we know there's 100 to 200 billion galaxies, each one of which contains 100 billion stars on average, give or take. That's 10 to the 22 stars, so that's a 1 with 22 zeros after it. I mean, if you could count 1 star per second, it would take you over 300 trillion years to count them all. So Jeremiah was right, although the best scientists of his day would have said he was wrong. In similar fashion, Psalm 147 says that the Lord counts all the stars by their names. Well, Jeremiah says that there's an uncountable number, but Psalm 147 says they are still finite. Again, this flew in the face of the best scientists in earlier civilizations. There have been many scientists and philosophers throughout history who have tried to say that the number of stars must be infinite because the universe must be infinite. Well, no, it's not infinite after all. Now we know this because we have better technology. The Bible's been right the whole time, even though for much of human history, the best scientists thought they knew otherwise.
It's interesting that God picked two numbers as a metaphor that actually match up pretty well. Really interesting.
The fact that there seems to be the same number of stars and grains of sand demonstrates the accuracy of the biblical account. But God not only shows His glory in the number of stars, but the creativity in making so many different kinds.
Lots of different kinds of stars out there. Most of them, 90% of them in our neighborhood, are what are called main sequence stars. And a main sequence star is a star that obeys a particular rule such that if it has a certain mass, you know everything else about the star. That mass will determine its temperature, its size, everything about it.
Our own sun is called a main sequence star, sort of average heat and size and temperature, and that's probably where 99% of the stars are.
If you find another sequence star that has the same mass as the sun, it will be the same size and the same temperature as the sun. It obeys that rule. It's kind of neat that it works out that way. And that rule is such that if the star has less mass, it will be cooler, smaller, and therefore redder. So red dwarf stars are not very massive. Those are the smallest type of star possible. Then you get up into orange and yellow. The sun's kind of a yellow or white class star. And then when you get even higher up, higher masses, they start to turn bluish, and so you get blue stars. Vega's slightly bluish, Sirius, and some of the stars in Orion's belt are blue stars. Blue stars are always more massive than the sun. If they're on this main sequence, they're more massive than the sun. About 10% of stars are off the main sequence, and they're always above it. They're always above that main sequence, and those are your giants and your supergiants. And so they're larger than they should be given their position given their temperature, given their mass even.
There are some stars that are called red giants, 10 times bigger than our sun or 100 times bigger than our sun. They burn their fuel rather rapidly. They're like cars that get low mileage, and they do have kind of a reddish appearance. They're not as hot a temperature as our sun is.
And so they're larger than they should be given their position, given their temperature, given their mass even. And so we don't know exactly what's going on with those stars. My secular colleagues think that those are aged versions of main sequence stars, but I am inclined to believe that stars are all the same age, considering they're all made on day 4. And so I think there's some other explanation. They may have a different structure, for example, and various creation astronomers are looking into that very possibility. In addition to that, there are other objects that are not truly stars, for example, white dwarfs.
They are very hot, high temperature, but since they're small, they're difficult to see. Maybe the size of the moon or even smaller than that.
A white dwarf is, we think, where a star has, with the mass of the sun, collapsed in on itself. Maybe perhaps it's run out of fuel and it's collapsed in on itself to form an object no bigger than the Earth, and yet with the mass of the sun. Incredible. Just imagine the density of such a structure. And we find white dwarfs all over the universe. And they're white because they're pretty hot, but they're not fusing, they're not producing new energy, they're just sitting there and cooling off. Objects that are even more dense have been discovered, and these are called neutron stars. This is where a star even bigger than the sun, we think, has collapsed in on itself. The force of gravity is so intense, because it's got so much mass, that the atoms are crushed, and the electrons forced into the core, into the protons, and they neutralize and become neutrons. And so it's made out of pure neutrons.
A neutron star, if you could take 1 teaspoonful of its stardust, it would weigh more than Mount Everest. And we see these kind of stars. That's another name for a pulsar, a neutron star. Very dense. There's some interesting, very extreme stars in space.
Pulsars are just neutron stars that happen to be spinning, and we happen to be lined up with the North Pole or South Pole axis of the magnetic field when it spins around. And what happens is it channels radiation along that beam. And so from our perspective, you get a little blip, 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 like that you can detect on radio.
It's as if these stars have collapsed, and so they're going faster and faster, kind of like a skater when he or she pulls their arms in. And some of these stars spin much faster than 1 time per second, 1 time per millisecond, very high speeds. They also have hot spots on them, and so every time the star goes around, it can send a beam of light our direction. It's almost like a searchlight going off and on.
When they were first discovered, they were called LGMs, for little green men, because they thought maybe they were alien signals. No, they're not. They're just a collapsed star that happens to be spinning quite rapidly, because as the star collapses, it speeds up, and pulsars spin very, very rapidly. Presumably, all neutron stars are pulsars. It's just we can only detect the pulsars, the ones that happen to be beamed right in our direction. And a neutron star would be no bigger than, for example, Dallas. Yet it would weigh more than the sun. Incredible density. And we think that if stars are even bigger than that, if they collapse in on themselves, then even the neutrons can't prevent further collapse, and they crush each other and become a black hole.
I think there's good evidence for those. Those are sometimes stellar size. These are more massive than the sun by several times. But you also have supermassive black holes lurking at the cores of galaxies. Some of them at the center of our own Milky Way, it's about 2 or 3 million times the mass of the sun. We have quasars, some of the most distant objects in the universe. They're billions of light years away. And these things we think have supermassive black holes at their center. And they're very small, and they're putting off an unbelievable, unimaginable amount of energy. A wide range of different types of galaxies in between that are very active, doing some very peculiar things. We're always being surprised by new things. Quasars were discovered in 1963, that's my lifetime. Pulsars and black holes when I was in junior high and high school. These are all new things that nobody saw coming down the pike on these things.
There are also objects that are not quite stars on the other end of the spectrum because they're not big enough. These are called brown dwarfs. A brown dwarf is something sort of like Jupiter, but bigger, but not big enough to initiate hydrogen fusion in the core, at least normal hydrogen fusion. You could get some deuterium fusing there. Brown dwarfs, sometimes they're called failed stars because they didn't have quite enough mass to become a star.
In 1 Corinthians, Paul says there's one glory of the sun, and one glory of the moon, and another glory of the stars, for star differs from star in glory. When you go out under the nighttime sky using only your eye to see, you don't see much variety. I mean, some stars are brighter than others, and there's a few that appear to have a little bit different color, but for the most part, they all look more or less the same. Now that we have telescopes, we know that stars come in a bewildering variety. All different colors, different sizes, different masses, different compositions, different configurations. Some are singles, some are binary, some are multiples. There's a bewildering variety of stars, which is how God created it to demonstrate His own glory.
So we live in a universe that's just full of surprises, full of diversity, something we might expect from a creator who wants to just kind of wow us and excite us and give us something to do, perhaps. And that's why it makes astronomy so exciting. It's always changing. It's not a static field in the least.
One of the most popular ideas right now is that the whole universe came into existence through the Big Bang, which ejected giant clouds of gas that eventually collapsed down into stars. The idea is that the starbirth is a completely natural process that has been repeated for billions of years, but do these ideas match reality?
This topic of stellar evolution is very popular today, and it's a model of how stars are born and how they grow old and finally disintegrate finally. Now, I believe that on the fourth day, God made all the stars and all their varieties and all the types of stars we see.
As far as star formation is concerned, secular astronomers, evolutionary astronomers require star formation. The reason for that is the universe is supposedly 13.8 billion years old, and many, many stars we see have lifetimes, computed lifetimes far less than that. Their own sun is 10 billion years, which is quite a bit less than 13.8 billion. So obviously most of the stars in existence could not have existed from the very beginning in this worldview, otherwise they'd be gone by now. So they have to hypothesize that stars are forming today, have formed for a very long, and will continue to form. They now believe that many stars formed very early on in the universe. They call this a starburst. They see a very distant galaxy where they think this is taking place. And basically, you read this in textbooks, it's amazing. They say that early in the universe there was a burst of star formation by some unknown mechanism. That's not science, that's again philosophy, theology, or it's storytelling, myth-making again. You hear these pronouncements from scientists about how we know how galaxies and stars form. That's rubbish. That's not true at all. There's a lot of debate and discussion about it, and people think they know the answer to it, but if we knew the answer, there would be no more debate. Now, would there be?
Astronomers have put together a pattern that a star is born from a dust cloud, then eventually it turns into a main sequence star like the sun is, and after that eventually into a red giant, and much later than that maybe into a white dwarf. It's like a whole sequence of aging of stars.
We see a vast amount of gas between the stars and the galaxy, and so presumably these gas clouds collapse down to form stars. To require that to happen, you need to give them a jump start, because Sir James Jeans worked out a calculation in the early part of the 20th century, probably the 1920s I'm going to guess, where he showed that if you have a gas cloud of a certain mass and temperature, gravity will indeed collapse it to form a star, but only if you get it down to a certain minimum size called the Jeans length. And all the gas clouds we see are many orders of magnitude, many powers of 10 larger than that. They're not anywhere close. You have to compress them down to get them down there by various mechanisms, like a shock front from a supernova explosion or cooling from dust grains or whatever. And all of those require that you first have stars to make the dust grains or to have the supernova explode. So it's a chicken and egg sort of problem.
And I think that it's probably not possible, or at the very least, it would be very rare. Because at normal temperatures, normal pressures in space, the nebula, it tends to be expanding. Gas wants to fill its container. It doesn't want to collapse in on itself.
So the gas pressure issue with star formation is fairly easy to understand. So I have a can of compressed air here. So this is a system of high pressure gas in a lower pressure environment. So what happens when you squeeze the trigger and you open a connection, a pathway between high pressure environment, low pressure environment, is that gas, of course, comes out. Well, why doesn't it work the opposite way? If I open a connection, why doesn't all the air in the room get sucked into the can, creating higher pressure here and lower pressure? Well, obviously that's silly, that's not how it works. Gas always travels from higher pressure to lower pressure. The only reason I can have a collection of high pressure gas is because it's stored in a container. But obviously when dealing with gas clouds in space, there is no container. So what is there to prevent a gas cloud from dissipating into space? Remember, it's high pressure gas in a much lower pressure environment. Using this as an example, we can see then why a gas cloud would dissipate. You need something strong enough to overcome that dissipation. You need a tremendous amount of gas to cause enough gravity to pull together against that. But this is where the difficulty lies.
Once you make the star, its own gravity will hold it together. But to take something as big as a nebula and expect the gravity to outweigh the gas pressure, it just never does. By the way, my secular friends know that. They know that. So they'd say, well, there must be something to compress it. And what they would invoke is they'd say a supernova. So an exploding star here causes a shock wave. I've done the math, and I think you need several supernovas simultaneously to make this happen. So I think it's very unrealistic. But even given that, wait a minute, if you need a previous star to make a star, who made the first stars? You got a problem there. In the secular view, it just doesn't work.
Furthermore, the gas clouds, the reason why they don't contract on their own is you have hydrostatic equilibrium. The inward force of gravity, feeble as it is, and the outward force of pressure, as feeble as it is, are balanced pretty much. If you scrunch it down, it'll re-expand. If you expand it, it'll recontract. So they're pretty stable, we say, against collapse.
Turns out that in order to get a star to form, you need to somehow cool this cloud of gas. The more you cool it, the less the gas pressure is there to prevent collapse. And so the question is, how do you cool the star? There's only one way I can think to do it, and that is dust. Dust around a star will tend to absorb the heat and radiate it out into space. Dust is good at radiating heat away. But where does dust come from? Well, in the secular view, it comes from stars. And so the first stars shouldn't have any dust in them. They should never have formed because there was no dust available right after the Big Bang, and again in the secular model. So how do you make stars? You need a previous star. Even then they'd say usually there's a shock wave or something to overcome the pressure. You need a previous star to explode to make one new one. In fact, you need about 4 stars to explode to make one new one. That's not going to be a very efficient process. You're going to run out of stars real quick that way. So I think that's a problem for the secular view that we would say in a creation worldview it's just not an issue.
It appears the theory of star formation may have some pretty impossible challenges to overcome. What do we actually observe? Haven't there been several starbursts seen by astronomers?
We see all sorts of claims about observations of star formation. The process is very slow. We've been looking just a few decades, and the process can take hundreds of thousands or millions of years to take place. So if anyone suggests we've actually observed the birth of a star, they're not being very clear in what they're saying. They're a bit muddled in all of that.
You know, a lot of times you'll read in the secular textbooks or in a newspaper, you know, this is a star-forming region and what have you. The fact is, we've never seen a star form. Don't let anybody fool you. I've looked at many, many stars. I've been doing astronomy for a long time, got a PhD in it, and I've never seen a star form, and neither has anyone else.
What they show are a number of observations, in some cases photographs, that might be the sort of thing you might see if stars actually are forming through a naturalistic process. Well, I'm sorry, we've been fooled before. Back 100 years ago, the people were really agog of this theory put forth by Laplace and kind of cleaned up today about the origin of the solar system and of stars. And most material sinks to the center, becomes the protostar, and then you have the disk form into stars. And they looked out in space and they saw all these things in space. And they thought, aha, this is proof of this very formation of stars and solar systems as we think they should form. And textbooks and teachers 100 years ago would have included photographs of things like the Andromeda Nebula, they call it. I put it in quotes here. We don't call it the nebula anymore, but the Andromeda Nebula as proof of this theory. Again, a snapshot that they choose to interpret a certain way. Well, there was egg all over their face in 1924 when Edwin Hubble showed the M31, the Andromeda Nebula. It wasn't a nebula at all, inside of our own galaxy. That is not a cloud of gas forming into a star, but instead was a collection of billions of stars we call a galaxy, the Andromeda Galaxy. So when they show me pictures today, I'm not terribly impressed because we've been fooled before by these sorts of things.
But in a creation worldview, it's not a problem. I guess if God wanted to make new stars, it's not a problem for him, but I'm inclined to think that all the stars that exist were made on day 4 during the creation week, and we certainly haven't seen any new ones that have been born since.
Stars show the glory of God by the sheer amount and all the different types. When it comes to the greatness of God, we can also consider the unimaginable sizes and distances between them.
Measuring the distance to stars, that's kind of a key area because that's the size of our universe. And over the years, we've come up with several different methods for measuring star distances, more or less accurate, by the way.
And the reason there are several different methods is because the range of distances is so outrageous that no one method works over the entire range. You'd use one method to get out to a certain distance, and you'd use another method to go beyond that, but they overlap. And so you can confirm that the two distances, the two methods give the same answer in regions where they overlap.
Stars that are relatively close to us, those we're more sure of. And what we use there is a method called parallax.
And this would be sort of like if you point your finger out like that at a distance and then look at your finger relative to a background object, or look at the background relative to your finger and blink your eyes back and forth. Your finger will seem to shift positions back and forth as you blink your eyes because you're changing your perspective from one angle to the other. The Earth orbiting the Sun does the same thing. When the Earth's on one side of the Sun, it's like your right eye, and the Earth on the other side is like your left eye, and your finger's like a foreground star, a star that's relatively close, and the wall is like the background stars. And so, indeed, stars will shift their position, whether the Earth's on this side of the Sun or that side of the Sun. It's a tiny effect because stars are so far away, even the nearest ones. And in fact, the lack of apparent parallax, that shifting, the lack of apparent parallax was an early argument against the idea that the Earth orbited the Sun. Because they said, well, you know, if there's no parallax, either the Earth's not orbiting the Sun or the stars are so ridiculously far away that that's just absurd. Well, it turns out they're ridiculously far away. That turned out to be the answer.
And so it's kind of like surveying, where you measure the distance to an object from two different points, and you can do the trigonometry and find the distance. And we've done that for thousands of nearby stars, probably out to about 1,000 light years. So those stars we're sure of. That would be the North Star and Arcturus, just a number of stars that you might have heard of before. Stars that are more distant than that, other methods have come along.
One of the easiest to use is called a standard candle. Now, a standard candle is where you have an object that has a known brightness, and you can measure how bright it looks, and knowing that brightness falls off as 1 over r squared, you can measure the distance to it. Just like you know a light bulb that's very bright is close to you, a light bulb that's up on a mountain is far away.
There's one called the Cepheid variable method. These types of stars have a very regular nature, the way they grow dimmer and brighter. They're actually vibrating inward and outward, kind of like a soap bubble. They change their shape. And you can graph that, and the pattern is so regular that if you find a Cepheid variable star, let's say in another galaxy, by measuring how its light is changing, you can determine how far away it is. And then you'd know how far away the whole galaxy is.
There's the moving cluster method, which is where you have a group of stars that are orbiting around in a massive cluster, and we can track their sideways motion, and we can use a Doppler shift to measure their forward-backward motion. And the Doppler shift gives us the true motion, like in miles per hour. The sideways motion would be just angle on a sky. You'd have to know the distance to convert it to miles per hour. And assuming those two are comparable, assuming that the motions sideways are similar to the motions forward, you can compute the distance. So it's rather remarkable.
Now, when it comes to deep space, then we use this thing called the redshift, the way their light is spread out just because of their motion. And we're less sure of that. Probably those distances are plus and minus maybe 10% or 20%. But the fact is they're a long ways away. And so the redshift shows us the distance to these stars, to these galaxies, as far out as you want to look.
Although we have never seen stars forming, there's great evidence they do die out. In Genesis 3, we read about mankind's rebellion and the curse placed on all of creation as a result. Could it be that stars die because of man's sin?
Now, we do know that stars die, so to speak. They do explode from time to time or collapse in on themselves. We know that happens. We have seen that. So that's good observational science there. It's not a problem. Some people say, well, that can't explain that biblically. And I'm thinking, the Bible doesn't say that stars don't die or that they don't fade away and so on. So it's not really a problem.
At the fall in Genesis 3, definitely all of the universe changed. Death entered the picture. The work by the sweat of our brow and the pain of childbirth, and even the animal world started to perish.
One of the questions people ask, is star death related to the curse? Is it related to the groaning of the universe? We know that all creation was affected by the curse. The Bible's very clear about that. In Romans 8, all creation groans under this bondage of corruption. Are supernovae a result of the curse? I'm inclined to think not, but I'm open to it. I'm open to it. The fact is we really don't know. What's considered bad? What is considered part of the curse? Well, a star exploding a billion light years away, it doesn't have any effect on life on Earth other than I think it's quite beautiful and it's fun to study those things. I don't necessarily think that stars couldn't have exploded before the curse. Some people assume that, but it's not necessarily the case.
This all involves something called the second law of thermodynamics, this deterioration, this idea that all of nature is wearing out, wearing down, and that's definitely true. And at least parts of that second law, that law of decay, either it began at the curse or it became more strengthened or more full. And so that's when you talk about a star dying, that's the second law, that's energy becoming unavailable. Whether that was happening at the beginning or not of creation, we don't know. If there was, then there must have been some kind of restoring mechanism to keep the stars going if there had not been a fall. So that's an interesting question, but I'd be careful about putting the curse on everything that happens in nature.
As far as a star dying, as Ken Ham frequently asks, when was it ever alive? You know, talk about a dead battery. When was the battery ever alive in the first place? So when we say that stars die, it's not death in the sense of the penalty of death. It's a physical process, like an explosion that takes place, perhaps. But that's hardly something that necessitates the curse. So I'm of the opinion that before the fall, there probably were some of these things going on in space, explosions of stars. Some people violently disagree with that position. So what can I say?
Again, I think this creation began fully functioning, and I don't know how much different it looked from today. Again, stars might have had lifetimes at that time.
I suppose in the initial creation that might have been an issue after a long time, after you run out of stars, but God could have created new ones. It's not a problem for Him. Why does it happen? Well, in the secular view, it's because they run out of fuel. That's possible. It's possible that God created some stars with very little fuel in their core. That's certainly a possibility. I don't want to diminish that. But on the other hand, it could be that there's some other reason why they blow themselves to bits. The fact is we really don't know in the cases of stars. For the sun, we know it's got nuclear fusion in the core because we can detect neutrinos from it. We know that when stars explode, they emit massive neutrinos, but in terms of what led up to that event, we really don't know. It's not like we can go and investigate. We can't go there.
Even though we can't travel to other stars, we can observe them from here on Earth. And as we do, we're always learning more about the creation. But what else can we learn from them? Some have suggested that they might even reveal the message of the gospel.
A lot of people have asked me about this idea that the gospel is somehow portrayed in the stars. I think that probably is not true. There are a couple different versions of the gospel in the stars. There's, let's call it the light version and the heavy version. The light version I'm sort of okay with. The light version says that people a long time ago knew about the gospel in some form. They knew that there was going to be a Savior who would come, and when they named the constellations, they named it with gospel symbols in mind. I think that's possible, but don't let anybody tell you we know that, because the fact is we don't know who named the constellations. We just don't have that information, and so it would be rather pretentious for us to go around claiming that we knew that that was the case. Then there's the heavy version, which I reject outright. The heavy version says that God Himself spelled out the gospel in the stars by the way the planets move and so on, that God intended us to read the heavens like a book and to learn the gospel that way. And I find that not scriptural at all. The Bible tells us, well, Psalm 19 tells us that there's a difference between God's general revelation that we see out in space and God's special revelation that we find in His Word. But if the gospel's in space too, then there's no difference. You could get the gospel either way. You don't need God's special revelation if the gospel's in the stars. And so the standard scriptural position is that we can only learn about the gospel from God's special revelation in His Word, and I believe that that is a scriptural principle, and therefore we cannot learn the gospel just by looking out into the universe. God didn't plant it out there for us to find. He wrote it in His Word, and that's where we read about the gospel.
By studying the creation, we can learn more about how God made the world. Creation scientists have invested their lives into investigating God's world to build the faith of others and find joy in their God-given pursuit. But Their work also brings them great joy.
As an astronomer, I'm always amazed there are people out there who can look up at the night sky and not be blown away with what they see. There's just something really special about astronomy, I think, that really touches the hearts and souls and minds of people. As we see in Psalm 19, the heavens declaring God's glory.
I feel very privileged that the Lord has blessed me with the opportunity to study His universe. And in terms of my personal experience, it's just strengthened my relationship with the Lord. The proper response to science is worship. And that's something that I have enjoyed myself.
The impact on me personally is I've always been fascinated with the stars and the heavens. I've mentioned before, I believe, about the fact that when I was age 4 or 5, I was having cosmological discussions as best as a 4 or 5-year-old could have. But some of my earliest memories are sitting on the front steps of the stoop of this place in the summer looking at the sky above us. I remember I was in 6 or 7 years old, 8 years old, maybe. I shined a flashlight at a star with my dad's flashlight, beeping little buttons on it to send a message to the star. It turns out it was Vega, I believe, in the summer. It's an easy to spot star. I didn't know what it was called then, but I now know.
I love sharing that experience with others. Yeah, like when they look at Saturn or something like that, they're just blown away. They say, wow, I can't believe that that's really there. And then they usually look down and tell us, like, are you tricking me? Is there a slide in there or something? No, it's really Saturn, and it really is just beautiful that way. And it's just a lot of fun. And when I'm done and I pack up the telescope and I'm lying in bed later that night, I just think back to the experience. And what a wonderful experience to experience the mind of God in a way that most people don't bother to, really.
It wasn't until I was a sophomore in high school that I felt the Lord wanted me to become an astronomer for His glory and His honor. And so I derive a tremendous amount of personal satisfaction from the study of astronomy, but I also derive satisfaction of bringing glory and honor to the Lord, and I have also the complete contentment that I'm doing exactly what God made me to do. It's not just personal and private, it's also professional. Everything about me with astronomy is just a wonderful thing. I can't imagine doing anything else. And I know there are many other astronomers who would agree with me, but if they're secular astronomers, they've missed the point. They're wasting their lives.
Well, I think it's good for all of us to get outside and look at the stars once in a while. And you don't need a telescope, just the unaided eye, and to get away from the city lights and just meditate and look at the sky.
We live in a world where most people can get access to a telescope these days, even if you can't afford to buy one. And they're really not that expensive these days, actually, but you can usually find somebody who has one, and what a wonderful, wonderful hobby. So I'd highly recommend to people, if they are interested in pursuing this, it is a wonderful field to get into. And you don't have to get a PhD in it to get a small telescope and to enjoy what God has created. He's placed that there for you to enjoy. Take advantage of it.
I think it kind of puts us in our place and makes us realize how small we are, this little part of creation. But at the same time, to realize that the God of this whole universe loves us and gave His life for us. It kind of shows, again, how small we are and yet how great the love of the Creator is. So that's all part, I think, of looking at the sky and just, I think we need to do more of that part of creation.
It's incredible to think that God is so powerful. He can create billions of galaxies filled with billions of stars just by speaking them into existence. Our problems might seem small by comparison, yet in Psalm 8, 3-5, He tells us that He cares about us very much. Stars are an incredible part of His creation, but we matter to Him much more. Still, we can look across the universe and proclaim, "The heavens declare the glory of God."